Boy, I got a lot to cover today. So I'm here to talk about QFW. And so what I'm going to try to do in hopefully 30 minutes or less than 30 minutes is to cover three things. What QFW is, where the work currently stands, and how to get involved. And that last one is me becoming a salesperson. So I have a computer science background, I'm sorry, but when I get to that point, I'm turning on full salesperson. All right, so let's get into it. I'm going to kind of speed through a lot of this stuff to get to what I perceive this audience will find is the really interesting stuff, and will generate a lot of feedback. So I'm going to speak through certain things. But as we started up openQSE and saw what was happening with quantum, we can see that there's a fragmentation of interfaces. I mean, we've seen QEMI, QRMI. There's other things out there going on in different areas of quantum, and there's a lot of fragmentation going on, just like in the networking world. Back in the 80s and 90s, we had ATM and SONET, which came out of the telecom companies, and Ethernet came up and ate their lunch eventually. But for a while there, we had all this variety and all this fragmentation. And the poor users up high were writing their code to one or the other. And then when Ethernet won, there was a lot of rewriting going on. And I think there's a lot of users that were pretty upset that they had to rewrite their code to a socket interface, for example. And we're hoping to try to learn from the past and try to avoid that in the quantum realm. And so this is one of the things that we're seeing is happening right now. And openQSE's sort of mandate is to try to get us navigated around this to help out the users so they're not going to get stuck in the same situation that the networking people did. And things keep changing all the time. So HPC scheduling, Slurm and HPC schedulers don't currently work with QPUs, but that's something we're going to work on. And then portability, which is I've already sort of covered a lot of applications. So what is QFW? So in one sentence here, I put it down as it's an execution framework for running quantum applications against a simulator or hardware services. So it's one workflow from your laptop to the Slurm cluster. I'm going to be putting another curveball into this, which is something new that I've been working on, that QFW is also a place for experimentation. And I'll be getting a little bit more into that later. And this is all brand new. I don't think the people who originally started up QFW were expecting this, so they can yell at me, Thomas. So QFW has a distributed runtime, which is in the form of a repo called DEFW, which is Distributed Execution Framework. And that is really an RPC mechanism for connecting the clients to the services over an RPC mechanism. There's the QPM services, which stands in front of the execution targets, whether it's hardware like a classic computer or a QPU resource. And it advertises what the type and the capabilities are in sort of a distributed way. We have a common schema which was being called QHW. And this is one schema that we're trying to normalize to so the people who are writing applications or compilers have one view that they can trust, regardless of which vendor they're dealing with or which resource library they're dealing with. And then hopefully we'll get to a point where we can get one workflow in place, which allows you to run your application locally, especially when you're talking to a simulator. You can run it as in a Slurm allocation, or what we also have been able to do is to run all of this within a single Docker container on your laptop, which is how I've been actually testing and working with QFW today. Even on my Mac, I can actually be running this because it's nicely containerized with all the resources it needs. And so I can happily work with this in the container. And we can get to a point now where we can deploy these Docker containers on the HPC nodes. So it simplifies the whole management and administration of the QFW framework. This is the original picture for QFW, which is on the wiki page. I think we do have to do some updates to it as we've been learning things. So this is a little bit out of date, so I'm not going to spend too much time on it. But basically right now, it's something that runs underneath a Slurm system where we have your Slurm daemons either on your classical resources, your quantum resources. So in the case of, for example, if you've got a hybrid application, that is going to basically be, first you would do the usual Slurm D reserving, and then you come down and launch your application as a hybrid application, which say it's using Qiskit. Qiskit is going to be interacting with QFW. So this is where QFW comes into play. And that's your backend, and it has a runtime, and then it has the API that talks to QPMD, and it uses a service directory mechanism to find that resource and how to communicate to it over RPCs. Talks to QPMD for the particular resource, the QPMD resource that you want to interact with, and the QPMD will be using the libraries that you've been hearing about, this morning, QDMI or QRMI, and that in turn talks to the appropriate QPU resources. And the other thing that QPMDs can do is to work with two simulators which are built into the QFW framework. So if you're sitting on your laptop in this container, you can happily start doing your work to make sure that it can validate against a simulator before you then turn around and run it in a container on real hardware. Again, there's some other aspects to this that are not present in this diagram. We need to do a little bit of an update, so I'll move along. So zooming in on QFW, like what are the components of QFW itself? You've seen where it sits in the grand scheme of the workflow, but now what is it? We have the DEFW, which I've already mentioned, is the distributed runtime environment. We have the QHW, which is just a schema that we try to normalize things to, so that the applications and the compiler writers have a common view of the data. And then, of course, we have the applications. And this is the thing we're trying to protect. The ideal here, the hope, is that the applications write against the QFW services once, and then as all this world changes and goes through churn and we get different vendors and things come and go, these guys never have to change. They're written against the common specification, if you will. And that is when we know we've been successful. If people up at this level are able to try out different vendors' hardware without actually having to change their applications, then we've won. That's a success story. If these guys have to keep making changes, then that becomes friction for trying out different vendors' hardware. And so it's in the vested interest of the vendors and the library writers to use something like this to help protect them from having to change, to get rid of the friction, so that the people up here are happy to try out different, quantum resources and compare them and to go through this whole validation process. So we have the whole services layer, which contains many different things, which I'll be getting into a little bit later. And then that in turn talks to the individual QPM services that front the QPU resources. And then that works with the third-party stuff that you've been hearing about this morning, or it even talks to the hardware directly. But the whole idea is to hide these details from up here. So the four principles behind what you just saw, which is just sort of a repeat of the problems that we were trying to solve. So vendor neutral by construction, we're an open source group. We're trying to, be vendor neutral and also give the application writers protection from the differences between the vendors as much as we can within reason. And I'll also add my own caveat here without stifling innovation. I was one of the people working on LibFabric, and one of the things that was really hard to do is to give a common interface without stifling the innovation that was going on with the different network vendors. And that's something that I think is important, because especially right now with everything changing and going all over the place in the farming world, we don't want to stifle that, but we still want to protect the application writers as much as possible from all of that junk. HPC native, so working with things like Slurm and Spank reservations and GRES gives us the ability to work with what's already out there for HPC. And simulator hardware is one path, so you should be able to use the same workflow to work with a simulator as you do with hardware. And then open and collaborative, and that's the one where I'll be putting on my hat later to be the salesperson. Like let's all work on this together, because we all can benefit from it for various ways. Now this is my extra hook that wasn't there at the very beginning. So Thomas can yell at me if he doesn't like what I'm about to say. QFW, I see it as a perfect place for experimentation. The thing that we do when we write papers, right? So, and I've given some examples in here of things that I started to look at and consider, and even in case of transport do, where I started to realize that QFW is a place that I can branch off on my fork and create this whole new environment, like replace a whole layer with something that I'm considering, try it out, And if it succeeds, then merge it to master, but also put in an environment variable so that you can turn it on or off. So you can switch between the layers that you want to use. And so the one that I've started on already, and it's currently underway, is I wanted to ask the question, can we run the client-server interaction over libfabric, which opens the door to using like the Slingshot network on the Frontier machines? It also gives better scalability, like you can use RDM connections instead of it being connection based. So that opens up the door to having like all 9,000 nodes of Frontier talk to the same QPU resource without overwhelming it with all these connections. And also to open up the door to using RDMA, which may or may not be necessary. It depends on what the size of the data that we're going to be chucking between clients and servers. I don't know the future. I don't know even necessarily where we are today because we just don't know yet. But what I was doing with this experiment is saying, well, can we use libfabric to address these issues if they do become issues? And so that's one example. Others that have been suggested to me is there's been a call to say, well, for the RPC mechanism, we kind of rolled our own right now. Well, why not use the industry standard gRPC? Okay, great. Let's try it out and see how hard it would be to do that in our environment. And also, what kind of resources will it require? How difficult would it be? So here's an opportunity to try that out. Polling mode, I've kind of keep getting this thing where we may need to poll from the server side, the GPU resource for fault tolerance or what have you. And there was a suggestion of maybe using IBM's DPDK, and I have experience for this. I've done this before, and it can really create a lot of curveballs. It would be nice to have a branch where we try this out on the server side. And this will also be an opportunity to see, can QDMI and QRMI run in a pool-based environment like DPDK? Here we'll find out how painful it would be to do that, so that we can then say up front whether that's an option for the future or that's just like, whoa, let's not go there. That would be too painful. And then one that's come up and is a really hot topic is authentication. That's been mentioned, and I can hear that the resource layers are both trying to address this topic as well. Well, with QFW, here's an opportunity to try out authentication methods above the resource interface to see what works and doesn't work, and then can absorb it down into the resource interface later on based on having proven it in this environment where it's safe and collaborative at the same time. Anyways, those are just some examples, and I'm sure people in this room can immediately start tossing a lot more out there. And so this is where I'm sort of turning on my salesman hat. QFW, interacting with it, starts to create an environment of experimentation as well as stability for the application regs at the same time. All right, so that's what it is. Where we are right now, there are 5 work streams that are currently going on in different states. I'm going through each of these separately, so I'm just listing them right now, and then I'll get into them in a moment. So there's a shim layer that's going to sit in front of QDMI and QRMI, and I'll explain that in more detail when I get there. The libfabric that I just told you about, experiment. A C-based API, which kind of falls out from the shim layer. Again, I'll explain that in a moment. And then the one that I'm excited about and really want to get working on is benchmarking, because I'm suspecting if we can get a lot of benchmarking into QFW, that makes it even better as an experimental tool, because now you have a way to measure the changes that you've done. And that's not just performance, that's also correctness. That includes a lot of things that we want to measure in this whole middleware world that we're existing in. And then that gives us a way an automated way to make those changes in those experiments and turn around and generate beautiful reports of what that change means. And then that becomes the well source for papers and the things that we're all doing here. The last one is a local scheduler that's being worked on by Amir, and it's Thomas. Are you part of that too? So Thomas and Amir have been working on a local scheduler, which I'm just going to briefly mention. So let's dive into those 5 things really quickly. So this one I'm going to slow down a bit because I imagine this is going to be an interesting topic for people. So one of the things we wanted to do is to eventually get these resource management libraries with a common interface so that the application writers write to one interface, and then it doesn't matter at that point whether they're using QRMI or QDMI. Now there's 2 ways to do this that we see in the industry. There's the libfabric way, which is an actual implementation that has to provide plugins. And actually, this is how QDMI also works itself with the devices. But whereas you're at the device level, I'm talking at the library level, but using the same technique, right? So that's one way. But the other way is the MPI way, where it's a specification that people build their interfaces to that the users, the applications will expect. And doesn't tell you how to do that. Like it's not pushing you to use a specific library. When I started working on this as a shim, it was going to follow the libfabric approach, but I think it was Lucas that pointed out to me is the last thing we need is another interface, and I agreed with him. And so we wanted to then go with the MPI approach, but that could take a long time to come up with an agreed on specification. So instead, I decided let's do it as a hybrid. Let's start with the libfabric approach and build a shim QFW that sits in front of both QDMI and QRMI, helps us figure out what are the differences, where are the missing pieces, get some feedback from the users of what should be in that shim, which will also drive the changes in the QDMI and QRMI community. And then over time, as the QDMI and QRMI converge together on supporting this interface, we can eventually pull the shim out completely and let people work directly with QDMI and QRMI again. So that's the strategy. We'll see how it works. We're just heading down this path. The status is that all the code has been submitted for device introspection and circuit execution. I'm currently going through a process of running this against various hardwares. So I'm hoping to include IBM into that list of things that we try it against. The libraries can actually run, they can coexist and run at the same time. So for example, with this whole process, you can use QDMI to do some introspection work and then maybe run your circuit through QRMI. So it opens up the door for coexistence, and where one might be falling short, you can use the other, assuming that they both support the same vendor's hardware. That's a bit of a key point to this as well. But over time, again, with convergence, we have a way to then say, okay, now that they've converged on this, we can then come up with that specification and then get rid of the shim completely. I could say any questions on that, or or we can wait to the end. Okay, so I'll go on to the next one then. So the libfabric I kind of covered already. Basically, the ideal is that, in my mind, I'm thinking we want to have a way to be able to use the Slingshot network directly using UUIDs as identifiers rather than IP addresses. So we're immune to the whole, whether you're using an IP network or not, get to something that's a little bit immune from that. Open up the door to being able to use RDMA in case, even though it's a control channel, we still could get very large data transfers, and it would be really nice to be able to support RDMA to make that work better. And then, of course, the big one for me is scaling. With the use of RDM, we can have like thousands of connections, and it doesn't use a lot of resources, and it simplifies things greatly. So that is currently in review. I've put a bunch of code in to get support in. So phase 0 and 1, I have the virtual table. This is all done in C. So I have a virtual table that the libfabric calls plug into. So from Python's point of view, they're still just doing sends, receives, connects, and stuff like that. But under the covers, it's called through a vtable. It's calling libfabric code that's arranging the use of the RDM connections. I validated already locally on my machine using the shared memory provider. So instead of using TCP when it's local, it's actually using shared memory to do all of the RPC work that we have. I want to be able to start trying this out on the Slingshot network here, and also to start verifying that RDMA can be used effectively. And so those phases still to come. And for anybody who wants to use NVIDIA, this becomes the pattern for the NVIDIA to take their UCX interface and plug it into the QFW as well. So the opportunity for us to use NVIDIA networks, because they're certainly coming up with a lot of stuff that will be usable by Quantum. This created the actual platform for them to plug in their interface, UCS, into this and open up the door for using their networks as well. So the shim, as I said, is going to bring us to a point where we can have specifications that QDMI, QRMI, and any others that may come in the future can write to. Initially, I'd like to get that done as a C contract, since that seems to be a common base we can get QDMI and QRMI to work with. even though it's Rust, you can still have a C API, which you can modify if you wish. And that gives us a starting point for an actual contract. And so just arbitrarily, I've already created something which I haven't pushed into the system yet. But I wanted to start all the calls with QRI, which stands for Quantum Resource Interface. And it will have, because it's using a virtual table, there can be null pointers for things that are not implemented. And that will return back a QRI not implemented to the caller. So that way you can see what capabilities the library has to offer you and decide which one you want to call. Anyway, so this is something that I'm hoping to publish and get a lot of feedback from the community, especially the QRMI and QDMI people, and start to enhance it and expand it, and then go to the compiler writers and the other applications and say, what's missing from here? Because as Tony's had mentioned, there's not many calls necessarily to these interfaces. And so when I did the first pass at the C contract, I discovered it is quite small and quite simple. And so the question is to go to the users and say, what's missing from here? What do you still need? Let them drive an enhancement to this contract, if you will, and then have meetings with the different library writers and start to discuss how we can implement those and use this as a sort of a requirements gathering for resource interfaces. So this is the starting point. Now, I know a lot of younger people won't want to see C code, but unfortunately, given what QRMI and QDMI have been written, and we're starting there, but I can see eventually this will evolve into just like a interface design language, like an IDL of some sort, and then how you implement it, that's up to the library writers. The whole idea is the shim and this contract gets out of the way once we have a formal specification that people can work with and write to. And this is exciting one, benchmarking. We really want to get benchmarking with QFW because I think that's when this becomes the perfect tool for experimenting. And there's two levels to benchmarking. There's the end-to-end runtime behavior where you want to analyze where all the time is being spent, even the circuit running, and to look for correctness, for example. But then there's also, what about the overhead that we're creating in our own libraries, like QDMI, QRMI, and QFW's all its aspects. So we want to be able to measure both things and then be able to mitigate the differences. So what we have currently proposed, but no code yet, is to capture all of the measurements into the logging system that QFW uses under the QFW bench record tag. And then write some Python scripts to extract those as JSON records, and then have another one script that can take those JSON records and produce really nice tables, really nice human readable information, maybe even graphics, but also have another script that goes back to the JSON and can do an A/B comparison. And this is where we can automate runs. You can do several runs in a row, get the JSON of separate entities, and then run a compare, and then just publish the comparisons to where things have changed. Where they've gotten better, where they've gotten worse, where they went from correct to incorrect, things like that. And the idea here is to not write everything ourselves. There's benchmarks that are out there today, such as MQT Bench or BenchPress, and Qiskit is already there. The ideal is to put in the necessary infrastructure within QFW to pull this information out into one common format and then have that be made available. And then I had it suggested to me, there's other open source projects like OpenTelemetry, which has its own format rules. Perhaps we can, after this is done, extend this to also work with the OpenTelemetry open source format. So then all these front-end visual tools that are in that world can be made available here for visualizing all of the benchmarking going on. So this is just actually a first step. There's a lot of things we're going to be able to do to make this test bed more useful for doing what its name implies, testing things and measuring things and finding out what changes happen over time. Any questions on that? That's a pretty big topic, but a pretty important one, I think, as we're moving forward. Okay, so this is the one that Thomas will know a lot more. So, go ahead. There's another one. Oh, hey, hello, someone.
Go ahead. Hi, thanks. I just wanted to mention quickly, you were already talking about benchmarking. I wanted to let you all know that we're also working on the MQSS benchmarking framework. I'm sharing a few resources in the chat. This is fully compatible with MQT Bench, like you were mentioning, and we're also integrating Houston and a bunch of other things. So I will just leave the resources in the chat for you to check, and if you're interested, I can send you even more and get you in touch with the folks from our side leading this in what I believe is a very interesting project.
Perfect. No, absolutely. Thank you. That's what this is all about. I will absolutely update this very quickly to adapt to whatever you can give me and try to pull it in. Thank you. Thank you very much. Alex. Oh, Alex.
Hey, I just like since talking about benchmarking and sort of going down towards HPC type networking, to keep in mind that between the different modalities, there's quite a basically 3 orders of magnitude of difference in how fast they operate, right? So modalities like ion traps and neutral atoms, they operate more around like 1 shot per second. So like for many modalities, networking latency is not particularly important, right?
True. That makes sense. But one of the other aspects to use something like libfabric is for the scale of the number of connections you have and the resources they use and things like that. So latency is one part of it, but there will also be that component as well.
Yeah, no, it makes sense, and it makes sense to have it on the normal networking. It's just yeah, I mean the actual benchmarking of latency is quite specific. Thanks.
Exactly. Thank you. Claudio, yes.
Yeah, just a quick comment on the strategy that you're setting here, that you mentioned that you could include benchmarking, some actually existing benchmarks such as Benchpress and others. Mm-hmm. The benchmarks, usually they will measure what they are interested on, so which is below them in their up to the software layer. Another approach that we could take is measure the layer that we are more involved on, which is, for example, the scheduling part, the task execution part, accounting information part. I know that may not be easy to find metrics for that, but I think that would be a big contribution.
Agreed. Yeah, I am kind of going to myself go in and try to put in measurements where I can, things that I have access to that are missing measurements today. And that actually might direct the people that work on those components to absorb whatever we show interest in with our measurements. So I'm kind of hoping to drive those people to adding those sort of things. But yeah, I agree with you. And one of the things I was hoping to do is to tag what layer the measurement's taken from, so that you can say, I'm only interested in accounting, or I'm only interested in, networking, or what have you. And then because we'll have those tags in the log file, we'll be able to pull out just the metrics that you're most interested in. Otherwise, this could become very overwhelming if this is put in a table, for example. Yeah. Almost done. Oh, okay. So I mean, I can.
Do you have more slides?
Oh yeah, but I can certainly stop. I think the last thing was just to talk about the final work stream item, which is the administration and the admission and scheduling work that Thomas and Mary are doing. And so basically, there's 2 new repos out there. One's QHW admission and one's QHW schedule. Those were just created like not that long ago, like a week ago or something. The HQW admission is a credit system that tells Slurm whether QFW is busy or not. And this is starting simple, but I can actually see this will become a place to play around with different admission controls, which very much of interest to Slurm workflow, I believe. Also, this may be a place, I'm just guessing, this might be the place that some authentication might happen that I'm just guessing at. And then there's the scheduler, which once you get past admission and the job gets scheduled, there'll be a local scheduler, this here, that could either invoke it on the QPU or basically put it into a queue for a while based on needs. So this one is the local scheduler, not the global scheduler, but the local scheduler. That code is emerged and it's, Amir tells me it's been tested on real hardware yet. So that's, I think, and oh, and yeah, that's basically it for now. Then there's just my big advertisement, but I'm going to back away from that and say, hopefully what I showed you right now shows this is the cool place to be for experiments and collaboration. So let's go down that path. There you go. Questions? Comments, and again, you can talk to me anytime.
There might be overcoming people.